Okay, we are going to discuss integrals as accumulators, and this is notes that we will be doing in class. The video is for the people that are not in the class, also to follow along, or if you miss, maybe you want to go back and watch this one again. I also will have a webinar that I did not make that was made by the calculus teacher at Avon High School, who also works for Notre Dame for the state program. It's really a good webinar, not very long, comes with some practice problems. Big major concept. If you're going to only review one thing as a big idea, this would be one of them, okay? I don't know how you narrow it down to one, but that would be one for sure. Okay, so what we want to talk about is integrals as accumulating functions. Okay, so this is our notes page. And so if you think about when we first learned what a definite integral was, you had your little song, integral from the A to the B said, hey, is the integral of B less the integral of A. So if that's the derivative, we had a capital F here, but the integral of the derivative is the biggest y value minus the smallest y value. Okay, f of b minus f of a. We didn't think about it too much that way. We mostly just started doing integral rules. Okay, well, what you can do is you can change this formula up a little bit, and I'll show you what they do when I say rearrange. So they go like this and say, we're going to take the integral from a to x. That would be f of x minus f of a, right? F of b minus f of a. Well, if you rearrange this and solve for f of x, we get f of x equals, add f of a to both sides, f of a plus the integral from a to the x, f prime dt. So what that means, if you want me to translate that for you, f of a is the starting amount, the starting y value. So whatever you start with, or wherever you start, how much you start with, plus whatever happens with the change. This is the totaling of all the change. So if you're adding and subtracting, getting faster, getting slower, whatever that is your overall f of x. And most of the time when we were doing integrals, we focused on this. We did a little bit of word problems with the initial amount. You always have to remember the initial amount. So this is where the final amount equals the initial amount plus net change. Okay, and I want to go through a problem. We already did this problem. Actually, it was on a test, but you may not remember it. So what I would like you to do right now is to pause the video and mark on the questions any notes that you could make. So underline the key vocabulary word that you're looking for. Don't just straight up read this. Look for initial amounts. Look for rates. See what you know. Okay, go ahead and pause it. Okay, so if you see here, I unpause it, and you can look at what I underlined and marked up. Things to note, we have a rate. So G is the rate at which gravel arrives, and it's processing at a constant rate of 100 tons per hour. So that's basically like gravel leaving. Okay, so the first question, straightforward, is not an accumulation function. I want to spend a lot of time on it, but basically the first question, this is a calculator exam. You would just put this in your calculator, find G prime at 5. I'll show you the answer. And you get negative 24.588, and it says, interpret your answer in the context of the problem. The rate at which the gravel is arriving is decreasing. So this is the rate. So we're taking the derivative of the rate. So the rate at which the gravel is arriving is decreasing. Like really the second derivative. Okay. We're going to look at part B. This is one that has to do with accumulation. So if it says find the total amount of processed gravel that arrives at the plant during the hours of operations. Okay, so that the amount that arrives is not anything to do with what you start with. So if you go with an integral from 0 to 8, it's 8 hours. of our function, you already put this in your calculator, so you can just write g of t. That will tell you, that calculation tells you how much arrives. Writing the integral is 1 point, the answer is 1 point. Now, what we have to figure out for part D, and I'm skipping C, is the amount of unprocessed gravel increasing or decreasing. That just means you can figure out the rate there. But I'm going to skip down to D, because this one is an accumulation function. What's the maximum amount of unprocessed gravel at the plant during the hour's operation? Justify your answer. So maximums occur at closed intervals at the endpoints, and see that there, at the endpoints, and also at where the derivative is 0. Okay, so in this problem, the amount of processed gravel at any given time. So now we want to think about, call it A of t if you want, as the amount. The amount of unprocessed gravel is the initial amount plus however much is added or subtracted. So in this case, the initial amount is 500. That's way back up in the problem. If you look, we started with 500. Okay, and then to that, we want to add up the total change. So from 0 to t, and we're saying from to 0 to t because t is 8 at the end, but we want to check all the way along the middle. From 0 to the amount of gravel that arrives is g, and the amount of gravel that leaves is 100, and that's per hour. So since this is t, we want to pick a different variable. Let's call it, I don't care, a. So g of a, dA, whatever you, I don't think that will be a sticking point. Okay? So now, the derivative of the integral from the a to the x, f of t dt equals f of x. So we need to find out where this is at a max or min, because we're going to test our values. We know at the endpoints, at t equals 0, we had 500 at the place, and we know at t equals 8, we had our 825, no, yeah, 825.51 minus the 300 that was processed. Making a mess here. Okay, I think I got my paper squared away here. All right, so I decided to write it as an integral to help you see where that comes from. So we initially start with 500. If we're talking about our time from 0 to 8, we started with 500 plus the total change. The total change, this is added, this is subtracted. So we figured out the total added already. That was the 825.51 minus the subtracted, which would be 800 because 8 plugs in there. That the derivative or the integral, that's 100. So what we end up with is 525.551089. Check it with the calculator. So right now, I need to know, is there a place where the derivative is 0? The derivative of this needs to be 0, because that could be where maxes and mins happen. So go back to that a. If I take the derivative of a, so a prime, the derivative of 500 is 0. The derivative of the integral, remember this is the derivative of the integral from the a to the x, f of t dt equals f of x. In this case, g of a, ga equals, I don't know, get the letters mixed up there. But basically the shortcut is you're plugging t in there when you take the derivative. So this is g of t minus 100. So the place where that derivative is 0 is when g of t equals 100. And